Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have a super cool, vintage, late 70s Williams Time Warp, a pinball journey into the future and the past. Pinball machine here in our shop that we had a gentleman bring us. And needs a little bit of repair. From what I understand, it's just some minor stuff. But we figured we would film a little video of it and show off this really cool machine. You don't see stuff like this one too often. There's a period there in the late 70s where the games were kind of simple, but were the new solid state ones, and some of those don't pop up that much anymore. So I think we had one of these a long time ago. Actually, you know what? I think I'm getting it confused with Tri-Zone. We've had Tri-Zone, but I don't think we've had Time Warp, so we're going to play it a little bit. So the first thing I notice is that the cabinet looks really cool. As a matter of fact, after I look at the cabinet, I'm thinking maybe this was a little later. So this may have actually been 1980 or so. We'll see if we can find a copyright date. Of course, you folks already know when it was because I probably put it in the title after I researched it and edited this film together. So, the gentleman has done some work on it himself. He told me he got a good deal on it. So he's put some blue flipper buttons on it, it looks like to me. And you know what? I approve. I think that looks great. So there's that. And this is one of the few games that features this. Now, if you're a little younger, you have probably never seen this. These are called banana flippers. And so this was an idea that Williams tried for just a couple games, thinking that with the flippers curved, it would change the way the game plays. Now, this is a standard-sized playfield. It kind of looks wide, but that's just because of the camera angle. But it's just a standard-sized playfield, but it has banana flippers on it. Some people hate these things because they're no fun. I mean, those people are no fun. Oh, if anything's different at all, oh no, oh, can't have that. So, of course, they would never like banana flippers because they're not like the other flippers. They're different. And some people hate change, right? So, but the game came with them, and it's kind of cool. It's kind of unique. Yeah, they probably don't play exactly the same as a regular flipper, but you could probably get used to them. So we'll try them out. What do you think about that? If we can get the thing to work, hopefully we can get it to work. I believe it already works, but just needs a little bit of help. Now, this is one of those absolutely ridiculous themes that some of these games had. So you've got some dude here. He's like, "What's up?" Right? And then he's got a pyramid, which, you know, is kind of like that's like a secret society symbol. And then there's a couple snakes. And then there's all kinds of moons and planets. And it looks like maybe he's controlling them with his hands. And then over here, there is a Tyrannosaurus Rex, because why not? Or I think that's what that is. And then there's a rocket, because that's cool. Over here, there's a moon man. Or I guess he's on the moon. I don't know. I don't really look like the moon. But whatever. He's out in space. He's doing a spacewalk, I believe. And over here, there's some fiery something or the other. And then there's a person behind a veil or something. Right? And then here's a knight on some kind of steed. And here's another one. And then you have this interesting figure on the pop bumpers. And a pterodactyl. Look, folks, I don't know. Maybe the back glass will tell us more information. So yeah, there's the guy in the middle. And so now we have... This looks more Egyptian. not immediately recognizable as Egyptian, but it, you know, looks Egyptian to me. And then it looks like he's got different things behind him. So you've got the space scene up here. You've got the European inventor and artist stuff here, you know. So this is like Greek and Michelangelo. Leonardo. The Mona Lisa. Michelangelo's David. Okay, and then down here you have the Crusades or something like that effect. Some kind of whatever. Okay, and then over here you have the dinosaurs up there, not sure what that is. And down here you have I think a woolly mammoth and some kind of big lizard and a couple guys fighting. Okay, so there's a lot going on here. Time Warp, a pinball journey into the future and past, it says. So I guess that's the theme of it. Okay, so before I plug them in, I like looking in them and just see what's going on. So let's open this sucker up. So how long have we been filming here? About, let's see if I can tell. It hasn't been too long, has it? Looks like 6 minutes, 7 minutes, okay. All right, so let's look in it. Now, Joey always leaves me a note. Yeah, I've been setting it up for 7 minutes. Joey always leaves me a note telling me what's wrong with it. So we'll know what to look at, okay? So he spoke with the customer, and I've been telling him we need a detailed list of everything they want us to look at on the pinball machine, because we might not know. There may be like a little switch up here that's been problematic and they wanted us to look at that, but if I don't know that, I might play it, and the one time I play it, it works fine. Or maybe I don't even hit that switch. So to be thorough, we need a detailed list. So he told me that he's going to start doing that, and he would leave the note on the machine or in the machine or something. That's locked. There's a lock up there. There's this bag. Nope, no list there. Let's see. It's got the key in the front. Let's see. Oh, come on, Joey! It's supposed to be detailed. I told you about this. This is... Whew, okay. All right. So I opened it up. And this is what we're looking at inside. There's a folder in there. I'll bet that's got the manual, right? Solid State Flipper Maintenance Manual. Very cool. Time Warp Prototype. Tri-Zone Production. Laser Ball and later games. Boy, that's so cool. Alright. Notice this game uses new programming methods. Alright. And then, boy, that's some rough sandpaper. Coarse. That's some coarse sandpaper. And then there's just a few things in here. Some pop bumper skirts. Maybe they swapped them at some point. A few rubber rings. These are the little covers that go on the coin switches. This is a pop bumper bracket. Some solder. And this is a pop bumper reset plunger. So just a few little random things in it. We've still got it unplugged. So this thing has a ton of pop bumpers. It's loaded with them. Absolutely loaded with them. And a kick-out saucer up there. And then a big bank and a smaller bank of drop targets. So 1, 2, 3, 4, 5 drop targets and 3 drop targets. And then your standard 2 kickers and 2 flippers. Tons of lights. Never seen that before. Flipper set screw torque, 75 pounds. It's pretty cool. Okay, so let me lay it down and then let's look in the back box, see what we got waiting for us back there. Back glass came out easy peasy. Got their standard 6-digit display set. Brand new power supply board, Pintec power supply board. It's got their early soundboard in it. Looks like it's been recapped. Pretty clean looking MPU. The driver board, they always have problems with these resistors, but it looks really bad, but it's not really, it usually isn't something that needs replaced. Whenever you see all this dirt though, you know, it makes you think, oh man, they're burning that stuff up. So it might have cooked these. We've got there's a Steve, I can't pronounce his last name. The guy that does Steve, that does all of the AC repair videos here on YouTube. We subscribe to him on our channel. He went out to some guy's house and the guy said that he you know, the motor is messed up on his AC unit, and Steve has a funny accent. You know, he just has a funny way of talking, the way about him, and he's from New York. And he says, you're cooking it, man, you're cooking it. So every time we see that, Joey or I go, you're cooking it. In honor of Steve, who knows his AC stuff. Okay, so, all right, so we need to plug everything up, and then we're just going to turn it on and see what she does and what we need to do to it. All right, so I have long arms, so I just reached down in and pulled all the extra cables out. Now, on these Williams games in particular, you have to be careful whenever you plug them back in, because on some of these, there are two of these connectors that are one's white and one's black, but you can plug them in either way. And so it's supposed to be the white one goes to the white one, the black one goes to the black one. But on some of them, from the factory, they use the wrong color one, and you're supposed to cross plug them in. Well, how would you know, you know? So you kind of have to follow the wire colors, excuse me. On this one, you don't have to worry about that because there's only one big one. That's the same. So we'll start plugging these back in and get them doing their thing. And there's some like this that I believe may go to this. But of course we're unplugged. And you want to follow wire colors, you know. Now on this particular one, it's going to the transformer, so of course they're all different. But you can see white and red, and we're plugging in white and red, and then it's looping over, so that's another white and red. And you know, you can check on the manual if you need to, but basically you just want to make sure that it looks right. You don't want to plug in stuff that the colors of the wires are completely different than what you're plugging in. So there's a red one, a couple orange ones. The actual connector itself is black, and the other one is too, so it looks like that's proper, you know. And then you should also do it with two hands. So I'm going to go through and plug them all in, and this long one here needs to go all the way up here to the soundboard, because it goes to the volume control down inside of the cabinet. Okay, so I'll start plugging them in, and we'll see what we end up with. All right, they all plugged right in. Just took a minute. There is a little ground strap here that comes up, and you attach to this little post with a wing nut on it. And that ties all the grounds in that are in the bottom of the cabinet and the head. And you can see that the head has this metal plate on it. And then you can see that all of the boards are grounded with screws to the supports, and the metal plate in the head. So by doing that, all of the grounds are tied together. If it's a ground, it's tied to the metal, right? And then there's a wire, there's a strap tying all of the grounds in the bottom to the metal. So the coin door grounds are tied to the metal. It's just everything ties together all over the place. So because of that, these Williams games are pretty, they don't have a lot of ground problems because of that. Now watch us have a lot of ground problems because I said that. Okay, people have asked us about this big cap back here. How come you don't replace the big cap? It's because all that cap does is it's the filter capacitor for the lamp voltage. So on these games, the lamps strobe. So it's hard to explain, but they run off of 18 volts even though they're 6-volt lamps. So it's just the way the board does it. It strobes the power to them. So at any given moment, it's got about 6 volts running to it. But because of that, just the way that they work, it uses that filter capacitor to create the voltage with this little bridge rectifier over here, and you just hardly ever have to replace it. If it started messing up, you would just get some noise on the line, which would mean maybe the lights would flicker just barely, and you might not even notice it because of the way the things are strobed. So it's just that rarely needs replaced. Now you can replace it if you'd like to. If that was on the solenoids, you would probably replace it because it could do something weird. It might lock something on or whatever, but it doesn't need it for the solenoids. But if a lamp messes up, it like turns on, so it, it's not catastrophic. The solenoids have the ability to like burn up the coil because if they lock on a coil, you can have some problems. Okay, so there's that, and then these two little bridge rectifiers over here, we've done a bunch of videos where we talk about this. Anytime I don't mention this in a video, somebody's saying, oh, the bridge rectifiers. Okay, so on the first several Williams solid state games, and by several I mean it's like 30 of them, something like that. The power comes in, it goes to the transformer. You can look in the schematics and see this. It goes through a fuse and then goes to the transformer, and then the transformer lines all come off and go into the power supply where they run through fuses, except 2 of the voltages run through the bridge rectifiers first and then go through fuses. So the problem you have is if the bridge rectifier were to ever short, it could catch the lines on fire running from here to the transformer, because the transformer, the way the primary winding and the secondary winding and all the other windings work, the only fuse is on the other side of the transformer, and so you could get enough amperage running through a short on these bridges that it wouldn't blow the fuse way back here on the other side of the primary of the transformer. So what it'll do is it will start melting wires, and this is not a real uncommon thing. This has happened a lot. Now, it's usually not going to burn your house down, but it might burn the hell out of this transformer, the wires, smoke up this whole side of the cabinet. And it's happened many, many times. So I don't mean like this has happened 3 times. I mean, this has happened hundreds of times with different people. It happens a lot. It's happened to us like twice, just working on them. So, you can run it without it, but eventually one of those is going to fail, and whenever it does, it's probably going to burn up the freaking wire that's running to the from the transformer to the bridge rectifier. So how do you fix that? You take one of the AC lines that's running to this bridge rectifier, and you run it through a fuse, an 8-amp slow blow fuse, and then run a wire back over to here. So you put an 8-amp slow blow fuse in line in one of the AC lines leading to the bridge, and then you do the same with a separate fuse for this one. So we've done videos on that in the past, but anytime you've got an old Williams, you need to look at that. It's up to the machine called Fire. They made a machine called Fire, and that was the last one that had that problem. That's kind of poetic, isn't it? All right, so we've got it all plugged in, everything plugged up. I'm going to plug it into the wall, and then we'll turn it on, and we'll see what it does. You know, folks, I've been thinking. I was here the day they dropped it off, so I kind of remember what the problem was. It's something to do with this. It's like the kick-out holes aren't working right, and there's some targets that aren't working right. So we got to figure that out. So that's basically what we're looking at. But we'll see if the thing will boot. I believe it will. but I haven't seen it yet. So let's plug it up and see if she'll turn on. So we've got it plugged in. We're going to turn her on. Now, here's how I do it. Okay. You're going to turn it on and you're just looking and listening to see if anything locks on. Basically, if a coil locks on, you've got about 2 seconds before it starts blowing a fuse. So you want to turn it on and just see what appears to happen and then go from there. Sounds good. So booted right up. Boy, it has a unique attract mode. I don't think I've ever seen a game quite do it that way. Look how they've done that. Very cool, very cool. I like it a lot. Okay, well let's see. I don't have a pinball, I don't think. There's not one in it, I don't believe. Look. There's no pinball in there. Let's see if they left it down here for us. There's some light bulbs. There's the switches we were talking about. Rubber rings. There's that. There's that. I bet they handed it to us and we threw it away because it was rusty or something. I bet that's what happened. Let me go grab a new one. Alright, nice new shiny pinball. Okay, let's see if she'll start if I hit the start button. Yeah, buddy, they did. Okay, now we're going to play finger pinball. That one's working. That one's working. And that one's working. That one's working. Okay, let's try the pop bumpers. Whew! Don't try this at home, folks. That one's working. It's a little, see how it'll work up here? But not every time. So we need to mess with that. I can see one of the problems is there's some mylar there that's lifting up. So that's part of the problem. That would be a good thing to just cut off, I think. Alright. Did we do this one? And this one bit me. And this one. And then this one. Okay. There may be something with the light bulbs. I don't know. We'll check the bulbs later. Okay, so they all work except that left one's a little touchy because of the mylar, maybe. There's a gate there. Okay, there's a little stand up over here. It's working. There's a little stand up here. It's working. Out lane. In lane. Out lane. In lane. Kicker. Other kicker. Ah! We got a dead kicker. Seen it a million times. That one kicks good. Okay, let me write those down. The left pop bumper, left top pop bumper, and left kicker, and then we need to do these saucers. Alright, so I wrote those down. And we got to do the drop targets too. So let's see if this one works. That one's working just fine. Okay, so now it's telling me to hit that target. This plastic is cracked here. So I think I'm just going to take it off so that we can manipulate the target. If it'll come off without cracking it even worse. There we go. Sweet. I'm so strong I was able to just twist the nut off. Okay, look at that beautiful little setup. So you would hit the ball up here. It would come up, hit that if you hit it good enough, and then come back, hit this gate, and then roll into this saucer, okay? Now on a newer game, it may be smart enough to understand that if it hit that, the next switch it should hit is the saucer. But on these older games, they didn't really program them like that. Okay, so if I look down in there, see how the switch is a little off? But it's not rubbing, so it'll probably be alright. Okay, so let's see if that works. Whoop. Whoop. Seems to be working just fine. So we'll have to play it a little bit later just to make sure that's all right. But we have a little minor issue with the left pop bumper. Left kicker is definitely not working. Let's try drop targets. They may need cleaned. That one worked great. That one did not. That one did not. That one did not, but it could tell all 5 were down, so that's good. So that one did that time. Or maybe it just hit this. Watch it now. Hold it now. Okay, so those need cleaned. That one seems fine. Let's see the one behind it. It's just fine. Okay, so our main thing is that left kicker. And let's see if it'll... Oh, we have a display thing too. Okay, so let me write that down too. So the display, top left digit. See how it's on 2 of them? So that tells you a little bit. It flickering like it's doing right now is just the camera. So players 3 and 4, the top left segment, not digit, it's top left segment is messed up. And drop targets need cleaned. Okay, let me keep making my list. Okay, so one of our viewers keeps mailing us these. We've got several shipments so far. This is a caricature of me working inside of a pinball machine. See a little rat on the floor that got out of the machine, and the little sprog, and the flipper rubber, and the multimeter, and the flux capacitor, a light bulb, a couple quarters. Look at all that. Look, the thing's still live too. See the electricity? We're fixing this sucker. Okay, so I made my little list on his beautiful pads that he sent me. Time warp. The left top popper. The left kicker. The player 3 and 4 top left segment. The drop targets need cleaned. There's a few light bulbs out. The bridge rectifier fuses and batteries. We're not going to change the batteries. We're just going to make sure they understand that you got to swap them out often. Once a year, folks. January 1st, swap your batteries. Okay, so we'll start working through it. So the left top popper, I'm just going to cut off the mylar that's keeping it from laying flat. The stuff is puffing up a little bit. So the customer did the cosmetic stuff already. They don't really want me messing with that. They can do that. But I'm just going to cut this off since it's already came loose anyways. And then we'll adjust the switch a little bit on the bottom, and that should get that playing good. So let's mess with it. Okay, so I cut off the mylar ring that was sticking up, that was just hanging there. It was no longer attached to the playfield. So it's a little dirty now. Whenever he goes back in and cleans this up again, he can get some of that residue off maybe. but it was just sticking up in the air, keeping this skirt from going down. So now the skirt can move well all around, everywhere the ball can hit it. So it should work a lot better. But we're going to raise up the playfield and look at the switch underneath it to make sure that it can hit it well too. Okay, so on the left side, we've got the playfield up. So this is the bottom pop bumper at the top, and this is the top one that we were having a little bit of an issue with. So the bottom one, if you look at the switch here, see the gap in it? It's not much. About maybe a 1/16 of an inch, something like that. But then if you look at the top one, see how it's much more? Right? So the skirt just has to move a lot to be able to touch that other blade. So we want to bend that a little bit, take up some of that distance. It's not quite good enough. That seems better. Yeah. That's more like it. Alright, so we'll try that. Alright, let's see what kind of pop bumper action we get. Oh yeah! Well, that's some action. Snappy, baby! That's how you want it, folks. Just a little adjustment of the switch. Cleaning up the Mylar that was in the way. Couple physical problems, okay? So I think that's good to go. Get rid of that. There we go. Yeah. Let's see what's next here. Let me drink some of my drink here. All right. Left kicker. Let's check that out. Okay, folks, so looking in the manual, the left kicker connects through here and is driven by Q29. But let me tell you another thing that I noticed just looking at this. The connector on the driver board, it's pin 1. Anytime you have anything acting up that's at the end of a connector, so pin 8 would be another one. Or I'm sorry, pin 9 would be another one. Anytime it's one of the signals at the end of a connector, often that's a problem with bad solder joints. So we're going to pull that sucker off, and we're going to look at pin 1 and see if there's a bad solder joint on 2J11. The 2 signifies the board, I believe. So 2J, and so J is the male part on the board, and then P is the female plug that plugs into it on the board. And so that one says 3J and 3P, and then the 3 is the third connector on that board. So 3 must be the power supply, 2 is the driver board. So there's another connector that goes to the driver board for more of the solenoids. So on the driver board, connector 2J11 pin 1 may have some bad solder. That may be the whole problem. Or Q29 could have a problem, or something upstream of that. But that's what we're going to look at. The actual solenoid on the left kicker, they've already replaced, trying to troubleshoot it. So it has a brand new, really nice solenoid on it, and the wires are soldered to it very well. It looks very professional. So a good job, but there's something on the board, unfortunately. So we're going to have to pull out the driver board, I think. Okay, so before we pull the driver board out, I'm going to show you a little trick. You can test the wiring in the game by shorting the transistor to ground. It will make the coil come on, and you can use that to tell if the problem is on the board or if it's the connection to the coil or the coil itself. So I just put that on ground. So if you hit the tab of the solenoid driver, it will make that coil work. Some of these are used for sound, like that one. That's the knocker. That one's either not used or not working. Not used or not working. Here, this is the actual one, the left kicker. Okay, so did you hear that? I'm gonna watch just to make sure. Yes, so the left kicker is kicking when I hit that. So what does that mean? Okay, we're grounding the transistor, which these chips are supposed to do, right? And then whenever we do that, it's connecting ground through the whichever wire goes through it. So from here to its plug, whichever one it is, through the connection, through the wire, all the way to the coil, grounding the coil. The other side of the coil must have power on it because it's going clunk and it's working exactly like it should. So we know the coil's good, the coil's getting good power, the wiring on the coil is fine, and the wiring up to and into the board is fine. There's just something's wrong with here or before here. Basically, the game is not able to tell this transistor to sync ground to that coil. And that's one of the other ones. That's a reset of the drop targets. Another sound one. Another sound one. Okay, so we know that ahead of time that the actual cabinet and the wiring is fine. We just have a problem with that. So I'm going to carefully remove this board. So there is a ton of connectors around the edge. And then there is this big 40-pin interconnect connector in the middle that joins them together. So we're going to carefully peel that apart, and then we're going to test that transistor on the bench and see if the transistor is bad or not. Got the board out. Okay, so these boards make a lot of sense. It's all compartmentalized. They just had it all on one board. So this connector goes to the MPU board. There is a PIA, peripheral interface adapter, on the MPU board that basically deals with the displays. So on the MPU board it handles that. This is called the driver board. This is Williams System 3 through System 7. This is called the driver board. This PIA up here handles the switches. And so the switches are in a matrix and are connected to these two connectors. And you have these 4 little support chips here. So the PIA is a 6821. And you have 2 7416s and then 2 that are very dark. Let's see if I can read them. I can't read them right now. It's some kind of normal support chip, like a 7404 or something like that. Anyway, we're not doing anything with switches though, so we don't have to worry about that. Now, like I was talking about earlier, these get so hot that it cooks some of this stuff sometimes. These 2 chips are support chips for the lights, and then of course these are the switches. So this is all switched lights. So it's any of the computer controlled lights that turn on and off during gameplay, not to be confused with the general illumination lights, which are just to light up the plastics on the playfield. So they are also in a matrix. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 columns. I don't know which ones are the columns and the rows, but 8 columns and 8 rows. It's arranged in a matrix. So this is all of the lights, and it's controlled by this PIA, peripheral interface adapter. And then the entire left side of the board is this PIA and several support chips to drive all of the solenoids. So it's kind of like they're doing all of this to buffer the solenoid voltage, which is, I think, 32 volts on these, to keep it away from the burning up the PIA. But you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You have 16 regular solenoid drives. And then you have 6 switched solenoid drives. It's basically, instead of the MPU telling it to turn on, although it can, there's a switch on the playfield, and if you hit it, it just kind of short circuits the solenoid and immediately turns it on. Now you would think that kicker would be that they would want it to react really quick, but it's not. It's one of these. So whatever. So basically, if this transistor is bad, hopefully it is, we replace that transistor and that will fix it. So let's look at the back. You can see the heat from those big resistors just cooks the board. But unless it gets really bad, it works just fine like that. Now, look at this. There's some corrosion here on the switch section. Look at that. That don't look great. So I think I'll take a wire brush and clean that up a little bit. It's working, but so you might say, well, where in the world did that come from? Well, think back to what we looked at earlier. It's mounted in there like that, and the corrosion is right through here on the back. Okay, so what's behind it? The MPU board and the battery holder is right there. So if the battery holder leaks, it would leak right down behind this board, and that's what you get. So that, when they say that it leaks, the batteries leak, they literally leak, drip alkaline out, right? And so sometimes, if the board fits through here, so it's sitting behind it just a little bit, it would leak and then hit this. The head usually is tilted forward a little bit, so think about that. So there's a battery pack right here, but the head's tilted, and so when it falls behind the board, it falls a little bit before it hits the board. So if it was tilted backwards, just from gravity, it would fall and hit the back of the cabinet. But instead, it's tilted that way, so it hits the board. All right, so I'll use my multimeter here. We're on diode test. Compare it to the working one next to it. Yeah, so you can see the leg that connects to ground has a different relationship than this one does. Okay, so between these two pins and these two pins, we're getting a nice voltage drop between 0.4 and 0.7. And on this suspect one, we're fine on these two pins. We got the collector, the emitter, and the base, but I don't know which one's which. But on one of them, obviously it doesn't have the same connection. And if you check other ones, same problem. So we're going to replace that that transistor. It's a TIP 120. We're going to replace it with a TIP 102. I'm also going to take a wire brush and clean off some of that corrosion we were just talking about. You can neutralize it with a little bit of vinegar and then clean the vinegar off too. Everything's working, and it's not really a problem with little tiny traces. It's just, and it's not on the front of the board. You've got big beefy traces with big beefy solder pads, so it's probably going to be all right long term, but we're definitely going to try to clean it up a little bit. And then we're going to replace the TIP 120 with a TIP 102. And then we'll put it back in, and that should get it going. Oh, I got to do the connector. The 40-pin connector up here. This thing is just, basically it has a certain number of inserts you can do, and then it starts acting up. So it's good to replace this and just get it freaking new. Look at the pins don't look all that great in there. The female end of the socket. So I'm going to take those off and put new ones on. So that's what we need to do to get the driver board up to snuff. So here's the old one. They've had a good run. Been in there since 1978 or so. Here's a new one. All new. And let me show you something special. They're gold plated. Nothing but the best for Tri-Zone. Okay, so we put a new transistor in. I guess we could clean that up a little bit. But I tested these and they're all still in spec. They're 27 ohms. 27 ohms. And they're all pretty close to 27 ohms. Little low, little high. Okay, so we're about ready to put it back in the game. I'll see if I can clean off a little bit of that, just to make it look a little better. And here we go. I think I said Tri-Zone again. Time warp. It's a time warp, people. Gold-plated time warp. Okay, dokie. Let's see what happens here. We got to see if we have made anything worse. You know, something might lock on again, or it might not boot. It booted right up. So the battery problem that we found on the other one, I'm not so sure it's from this board, or it may have been that just the holder had rotted, but that's a new holder and it seems fine. Maybe it was replaced and fixed in antiquity. Could be. Okay, so let's see. What in the world? Come on now. Well, that was a big waste of time. Okay, there's more than meets the eye. The ball fell down in there and did not kick out. Aha! So there is something going on. That's not making noise now. Remember earlier it was making noise. So there's something going on with the switches. Interesting. So sometimes it doesn't recognize that, and it never recognizes this. Well, it was, but now it's not, since we fixed it. Okay, well, the way you can... Switch matrix. Whoa! Perhaps it wasn't a waste of time. Okay. I've seen this same problem on a Firepower. And so basically, let me turn it off so you can hear me. Okay. So these are the switch connectors. Now, if these, on a Firepower, a lot of them are insulation displacement connectors. They're not Molexes like this. But basically, if this ends up being a bad connection, switches won't work. Because, you know, all the switch matrix plugs in these two things. On a Firepower, it's a particularly bad problem. Because on this one, whenever that happens, we're losing a couple of our switches. This one, when the ball lands in there, and the left kicker. But on Firepower, what happens is if you lose the switches that tell where the balls are in the trough, it thinks a ball is missing and the game won't start. And it'll crash the whole game. So on Firepower, whenever we work on those, we've started just repinning all of the switch connectors to make sure they have a nice good contact, because it's catastrophic if you lose that just for a little bit. The game won't play. On this one, it appears that we've got a bad connection there somewhere that's making this drop out and that drop out. Now, we tested that, and it was still bad. you saw whenever we tested it on the board. And earlier when this was working fine, remember when we hit that, it would go bleep, bleep, and make a noise. It just wouldn't kick, right? So we've got multiple failures. So basically, the solenoid driver was bad for that, but we've also got a switch problem, which would explain why he was saying that he was having problems with that. So I feel better now that we're actually seeing the problems that he had. Remember I was talking about Joe needs to make the note real, you heard what I said. So let's look in the manual and see if there's any correlation between that switch and that switch. Okay, so here's the switch matrix. So the left kicker is number 42, and the right eject is number 24. So there's switch 42, and there's switch 24 way down here. They have no correlation at all. So here's what I'm going to do. I'm just going to replace all of the pins on both sets of connectors, like we do on a Firepower, and then we won't have to worry about switch connections. And so we will know that it isn't the connector. There might be a problem with one of those chips. Maybe one of them got smoked by that resistor we keep talking about. But I'm going to replace those, and then we'll try it again and make sure everything works right, and keep our eye on it after we do that to make sure that it doesn't start acting up again. Okay, folks, I put new pins on both of those connectors, and I think we might have it. Maybe. Right. That might have done it. I think maybe we got that, but we'll watch it, right? All right, on to the next one on the list. Player 3 and 4's top left segment is not working. That's next. All right, so the first thing I did was unplug 3 and 4 and plug them back in. That didn't change anything, so it's still doing the same thing. So if you look on the schematics of the displays, one of these segments, A through G, is our problem. That's player 4 and that's player 3. And if you look, they're controlled by the same set of lines, okay? Because all this has strobing going on. And if you follow the lines back, they come out of this area. So they all run through 10K resistors. If one of those happened to be bad or not soldered well or got physically damaged or something, you'd lose one of your segments, only on the third and fourth player. Or if this 7180 was bad, that could cause it. It may cause it if the IC8 or IC7 are bad, because look, they have the A through G, and A through G is outputs there. Right? And then it's all driven by some BCD segment data. A2, B2, C2, D2. Now, if one of those was missing, you'd have a lot more messed up than just one segment missing out of the display. So, my guess would be it's the 7180 or one of these resistors. So we'll pull it out and look at it and see if we can figure it out. Okay, so in that section of the board, segment F is the one we're having a problem with, which is R13. And there's IC10 that drives all of them. Right, and if you look on the actual board, that one does look burnt. And then this one down here has been replaced. This one, it looks like, has been replaced, and it's also burnt. So we're probably about to lose segment E. So we need to go through and test those and replace the ones that need replaced. Now, unfortunately, sometimes whenever you got those burning up, it's because there's a short in the glass that's doing it. But we'll see. Okay, let's check them. We're going to do it in situ. Now, if you think about it, sometimes whenever they're in circuit, you can't get an accurate reading, but since we've got 7 of them here, they should all be the same because you saw how the schematic looked, right? And since nothing's connected to the one side, they should pretty much read right anyway. That one's about 10K. That one's about 10K. Now here's the suspect one. It's about 10K. Don't like the look of that. And here's this one. About 10K. This one, about 10K. Now here's the real ugly one. 10.6K. So that one, you know. And then this one, come on. About 10K. So here's what I'm going to do. I'm going to replace the ugly one. And I'm going to replace our suspect one, thinking that maybe once you run juice through it, the resistance changes. And we'll see if that fixes it. It could be that this chip is going bad and causing the problem, and that's why it's heating up the resistor. Or it could be that the glass has a short in it, either the third player or the fourth player one, and that's what's pulling the current through the resistor and heating it up. But if it's the glass, there's no repairing it. You can't get the glass anymore. So our easiest way to fix it is if it's one of those, if it's that resistor. So I'll put a new one in it, and we'll try it again. Here we go. Okay, folks. So when I plugged it back in, it was doing the exact same thing. By the way, the flickering that you're seeing is just the camera. Whenever I plugged it back in, it was doing the exact same thing. So I unplugged the fourth display, and the third display still had the top left segment missing. I unplugged the third display, plugged the fourth display back in, and by the way, you have to do that with the power off. And the fourth display is just fine, as long as the third display is not plugged in. So the problem that is going on is that the third display has a short in it. So the way to fix that would be to replace the glass or to replace the display. But if we plug it back in right now, it's going to pull down that line and get rid of the segment on the fourth display. It screws us up, right? And once it gets back to the board, all of those segments are both tied into the same resistors. So the way to fix it is you have 3 options. 1, replace the glass, but you can't get new glass. So you would have to use a new old stock piece. 2, replace the entire display. Same thing, they don't make a new one, you'd have to get an original one. Now you can get a new set of displays, but you'd have to replace all of them. So I guess that would be option 3, replace all of the displays with LEDs. Okay. Or you could do a little trickery. So we're going to do a little trickery. So I'm going to remove the display and we'll go put it on the bench in the back. Okay, if you look at this particular display, see all the burn-in on it? This thing is pretty old. It's also slightly different than the other ones. This is just a different display that they pulled off a different game. So I looked in the schematics, and the pin that runs segment F is pin 40. And so I just carefully desoldered the pin and lifted it up out of the hole so it's no longer connected to the trace, which means that the short inside the glass will no longer work, you know, so that segment will be permanently missing from this glass, but it will no longer drag down the other glass because that short connects through there back to the board and then connects to the other display and makes its segment also not work. So with this glass unplugged, the other one works just fine because of that one pin. So if I lift that pin, this glass is always going to have that missing, which is going to anyway, but at least the other glass will work, right? So I'm also going to swap them. So I'm going to put the good glass in the third player position and put this one way down in the fourth player position. So the only time it'll be a problem is if you're playing a 4-player game. And, you know, that'll do for now. Now, if the customer wants to fix it, he can get a new glass or he can get a whole new display and swap it in, or a whole used display and swap it in. But I talked to him whenever he came by, and I don't think he'll be too particular about it. But if he is, we'll explain to him what the deal is. And he'll watch this video, because he's one of our viewers. Okay, so this display works good. First player works great. Second player works good. Third player works good, but the fourth player, whenever it's showing certain digits, it's missing the top left segment. But that's as good as we can get it. Got to cross that off the list. Player 3 and 4 top left segments. Okay, folks, so that's it for this time. We'll have to do another video because we didn't get through our list. Ugh, it's a long list. But we're getting there. So make sure to subscribe if you haven't already. We'll do another video playing, fixing through the rest of it and then playing it a little bit. Make sure to give us a thumbs up for taking the trouble to film it for you. And don't forget to check out my brother, Donnie. My brother has his own channel here on YouTube. You can see it down below. There's always a link under all of the videos to go check it out if you haven't subscribed yet. What are you waiting on? I'm over there with him a lot on his channel. We work on pinball machines, jukeboxes, and arcade games on this channel, but on that channel we're doing home renovations, building renovations, working on old cars, basically just having a lot of fun. So we will see you over there, and we'll see you back in 2 days with the next part of this video. If this video is more than 2 days old, you don't have to wait. You can just watch it on our channel here. Alright, so we'll get back into it next time. I hope you enjoyed it, and this is William's Time Warp.